Yeah, good evening, everyone.
Good
So,
evening, sir.
yeah, thanks. I hope the screen is visible. So, we are discussing this metrology. So, this is the third class of metrology. Initially, there was a casting lecture. So, we discussed the basics of metrology, then the limits, widths, tolerances, then limit gauges. In this session, I will discuss these limit gauges and some other topics related to this. And there are the session is mostly towards the solving some gate questions, so there will be very less teaching, and if there is any time at the end I will explain the topics of next session also. So so any doubts till now? So the topics I covered earlier, any doubts regarding that? So okay, I hope everything is clear. So let us start with some before going to limit cases, there are some small concepts. Let us cover those. So, as you know, there are two types of tolerances. Uh, okay. So, can anyone tell what are those?
Unilateral tolerance and bilateral tolerance.
Okay. Okay. A simple example I will give. So, you are already familiar. Just small recap. Okay. So, okay. So, which is bilateral? This one. So, only these. This is for hole and this is for shaft. So, you have both the deviations. Say, for example, 50 plus 0.8 minus 0.2. So this type of nomenclature you can see it is bilateral. Okay. So this is just a small concept if you are already aware of. So let me discuss one more thing. So do you have any idea about this tolerance sink?
No, sir.
Okay. Any other?
No, sir.
Okay, nice. So so this is mainly in the design aspects. So what people will do is they intentionally will not give the tolerance for some part, uh, so that if there is any tolerance accumulation they can fill it in. Okay, so there is no need to give tolerance for every part in a assembly. You can leave one part without any tolerance so that you can calculate according to the dimensions finally. So it will be for easiness of the design process. So for example, so I have an assembly. Okay, this is my assembly. So now I have a tolerance for this, tolerance for this, tolerance for this. But for this dimension from here to here, so this I will not give in the design aspects. This total, but I will give the total dimension. So with the use of these values, I can accumulate all the tolerances in this dimension. So that is the concept of this tolerance sink. Okay, so just I will give the values. You try to calculate once. If not, I can discuss. So now I'm giving just the tolerances. You can just, so for a product, it is a plus or minus. So I will write here. For A, it is plus 0.2 minus 0.1. For B, it is 0.26 minus 0.17. Then for C, then for D, and similarly for E, it is 0.1 minus 0.3. Now just give me the values of upper and lower limit of F. So this is the size, this total size. So you don't need to worry about that. You just play with these tolerances and give me the values of upper and lower limit of this F value. Yes, spend a minute of time. Then if you're not able to solve, then I will solve it. So any ideas?
Maximum size of the A minus B minimum plus C minimum plus D
Yeah,
minimum plus
yeah.
C minimum.
You can give me the values directly. Yeah, that is the process. Just calculate. Meanwhile, I will also do here.
0.79.
Upper limit or lower limit?
Upper limits
0.79.
0.59 minus 0.59.
Okay. Lower limit? Okay. So, just forget about these tolerances for a second. Suppose if I want to get f value, normally you do the big size is a. You'll just subtract everything from this. Okay. So that is the process you have to start. Then just keep the limits, and you can write the limits of all others. Okay. So now if I want maximum of f, you have to take a max and you have to subtract the all b, c, d, e, everything, the minimum value of those. Then only I can get the maximum of f, and vice versa. If I want to get a minimum of f, I should take minimum of the big size, and I should subtract all the maximum of the all the tolerances. Okay, that's the concept. If you want to follow any shortcut, this is the shortcut. So you have to take a positive 0.2 minus all these values, considering this value as well. So that would be
0.89.
okay. So that would be like 0.2 minus of minus plus 0.17 plus 0.21 plus 0.31 plus 0.3. This is the upper. Similarly, the lower will be minus 0.1, minus into minus of plus, you will get minus, and similarly you will get minus everywhere. So that is. So what is this value and what is this value? This should be minus 0.89 and this should be 1.19. Please check this value once. Okay. So to get the maximum of f, you should take the maximum of the large size and you should subtract all the minimum values of these things. And similarly, the other vice versa for the minimum also. So I will give you just note down. So
yes, sir. Got it.
okay. So just note down in your book, and you can just see in your free time what will happen to these tolerancings in terms in the case of bilateral. This is the scenario of bilateral. Just think about it, and you can compare that with the unilateral also. Just you can make yourself how to solve these type of problems in quick way. So this is one shortcut, but you can find more. So similarly, same concept. So, but I have done for linear, similar thing happens in angular as well. Just suppose I have some angular measurement. So these are the angles. So I have the angle for this, that is 60 plus or minus 0.1, 112 plus or minus 0.3, 135 plus or minus 0.5. This is 30 plus or minus 0.4. Now you have to find what is this value as well as the tolerance. So now if you see, this is bilateral and equal. Not as in the case previously it was different, but here is the upper and lower, the tolerance values are same. Half tolerance value. So if you are wondering about maximum dimension, it has now it's 360 plus or minus 0.
0.0.
How much? You should get this value. Just note down the answer and you can
Yeah, sir, we are getting this.
okay. So yeah, these are the simple concepts. They are important. You can just have a look. It's very easy. So this is a bilateral tolerance. So there will be one logic. You just find out yourself.
Excuse me, sir.
Yeah.
So the previous problem, yeah, this one is actually bilateral only, sir. Already you gave.
Sorry, this one is
The problem which you gave, the previous one, the first
yes,
problem,
yes.
this is already bilateral, no, sir?
Yes, but not equal.
Okay.
Yeah.
But logic is same, no, sir?
That you should find out whether the logic remains. This logic is same. This logic will be same for everything.
Yes, sir.
Okay. But there is one more logic for if it is equal and bilateral. You can find. You can just write it down. You will get. You just have to add the tolerances. Just find it out. So we'll quickly move to the concept of today's concept, the limit cases. Yeah, you can stop doing and you can try it later. So this is an important concept, limit cases. So the main concept is the limit fits tolerances. Then comes to this limit cases concept. So in this, you need to learn about types of these limit cases, and then so these gauges will be designed on some three different types, three different systems, I can say. Then these are the two main things. Once it is done, I can the theory part, a little bit of theory what is there. So so you are aware of these limit gauges, go on no gauges.
Yes, sir.
Okay, then it is easier. So as you can see, you can just remember for anyone, either the hole or either the shaft, it will be the opposite. So in case of hole, so this is the tolerance they have given. This is the maximum limit. So this go gauge will be so there are some certain rules we have to follow. These are the basic rules coined by this Taylor. So what are the rules here? So the rules will be this go gauge which actually enters the this assembly. If it is a hole, it should enter, and if it is shaft, it should enter the shaft. So these go gauges should be for the maximum material limit. So that is one rule, and it should be in full form. It should not be in the case of hollow. It should be on full form. Then, so this no go gauges is for the minimum material limit. Okay, that is one rule. So why we do this go and no gauges is that so the inspection will be very fast. So if is it and this should be used if you want very high accuracy. You have to go for absolute measurement using some standard instruments, say vernier calipers or any programmable devices, say coordinate measuring machines. You have to use them. Even it is very costly inspection, if they are the products are very costly and very precise. If you want, you have to go for absolute measurement. But if the products are costless and they are producing in mass production, then you have to go for these limit gauges so that the inspection cost will come down. So and so these are the two rules. I will discuss the rules one by one. And the go gauges we for inspecting hole, go or no gauge, we call them as plug gauges. If we are inspecting shaft, anyone?
Snap gauge.
Ring gauge.
Ring gauge. Correct. Okay. Snap gauges will come. So these are the main things you have to go learn about, and how these go or no gauge will be, how these design will be made. I will explain while discussing the systems. Okay. So these are we have total three types of systems. One is the workshop gauges. The other is the inspection gauges, and the third one is the ISO gauges. So, so the principles. So each system is designed in some philosophy. So these workshop gauges. So and similarly we have shaft. Yeah. So these are the datum lines. So just for construction purpose, I have written. So this is the basic size. So we have some. This is the fundamental deviation, and we have a tolerance on the hole as well as on the shaft. Say by say x. So now the first one is workshop gauges. So in these gauges, so the philosophy is like that. So these so the workers, they believe that everything is made correct, so there is no wrong product made by them. So based upon these principles, the gauge tolerance will be inside the actual tolerance value. This is for go gauge, and this would be for no go gauge. Suppose this is x, this gauge tolerance always be x by 10. Okay. And if you want to provide any wear, so where will be provided only on the go gauges, because this actually enters the product. So that's why we have to provide the where on this. So this is the where, which is x by 100. It is the 1 by 10th of the this gauge tolerance. So on this top, I will have the gauge tolerance, and here I will have, there will be no wear allowance for the no-go gauge. So this is workshop gauges for holes. Similar, same diagram will be there, but it will be inverted in the case of shaft. Okay, just I'm not writing it for the time sake, but just will be the opposite. This will come here. This will be here. So now, so here the problem. So there is some problem with this type of system. So can anyone tell what is the problem in these gauges?
Excuse me, sir. What is that? Is it x by 10?
Yes, yes, it is x by 10. It's the tolerance of the hole. 1 by 10th of the tolerance of the hole.
So for shaft also it will be inward only.
What?
For shaft also
Mm-hmm.
it will be inward only, right, sir? For like similar to hole.
No gauge, you are right. This one. Yes, yes, of course it will be inward. So these workshop gauges, everything will be inward, inside only. Okay. So the second set, this is with wear elements. Okay. So can anyone there is something wrong with the system. That's why we moved to other systems.
पर x by 10 is मतलब उसकी वजह से प्रोडक्ट वो हो जाता है रिजेक्ट.
That's correct. So this is within the limit, but still we reject it. So that's the disadvantage with this. So that's why there is one more system, that is the inspection. So in this inspection, so the philosophy is we have actually kept so much of time and hard work on manufacturing the product, so nothing should go waste. So that's why that this gauge tolerance will be outside the actual tolerance of the products. But the value, rest everything is similar. So we create the go gauge for the maximum metal limit, and the gauge elements will be 10th of the actual elements. Okay, and if you want to provide this wear elements, so actually in inspection gauges we don't have to provide any wear because it is already outside. So if it is wearing out, there is no issues in that. So again, there is one problem with the inspection gauge. Can anyone tell what is that problem?
मतलब जो रिजेक्ट होने चाहिए थे वो भी रिजेक्ट नहीं हुए सर.
Mm-hmm. Okay. Any other? So these are not the so these tolerances are outside actual tolerance. So I am also accepting some of the products which are not in within the limits, as earlier someone said. So that was the difficulty with the inspection cases. So there are some products which are not actually within the range of my selection, but still I'm accepting it. So that's the problem with the inspection gauges. So then there was one more system, that is the ISO gauges. Unless otherwise specified in a question, you have to follow ISO gauges. So in these ISO gauges, there is no system in ISO gauges. So what the brilliant idea is, you take go gauges from the workshop and no go gauges from the inspection. So when you combine these two, it is the ISO gauge system. So so now what is happening is that, so it is like a in between the inspection and the workshop gauges. So still I have some rejection, some parts which are not within the limits, and still I have a products which are within the limits, but still I am rejecting. But compared to these workshop and inspection, these ISO gauges will accept most of the products which are within the range, and some we have to uh, you know we have to remove, or we have to reject. So that is the term we coined as necessary evil in metrology. So that necessary evil comes from the manufacturing side, because we cannot produce any type of product, the same product twice or thrice, because of some of the, even if you follow same process, same system, same machine, same skill man, we will not get the exact product. So based upon that, we have to reject some parts. So this is the process, this is the classification of processes. So now, unless and as otherwise specified, you have to follow ISO gauges. That is, so here, so this is the wear, and this is the gauge tolerance for go gauge, and this is gauge tolerance for the no go gauge. This system is for hole, and similarly, it will be same reverse for the shaft. Okay. And this is this is the weight tolerance that we produce. Okay.
Excuse me.
Yeah.
So for inspection, there is no variance.
Yes, yes. Because they are already outside the desired tolerance. Even they wear out, that doesn't affect my product quality. But in ISO and workshop, we have to provide wear, because they are within the limit of our selection. Okay. Just remember this diagram. It's quite simple. So any doubts? So say,
In a
yeah.
upper line for shaft tolerance, that is related to go gauge, na?
Yes, yes, correct. Maximum material limit. You see the maximum material limit every time. Maximum material limit for the go gauge. So you can remember like go max, no go mini. So this is, just to remember if you are confused. Go gauges will always be designed for maximum material limit, and no go is always designed for minimum material limits. You can just remember these two terms.
Excuse me, sir.
Sorry?
Sir, for the workshop pages, like for the
Yeah.
no-go, we don't have any variance.
Workshop gauges, no go gauges. Of
We
course,
don't have,
no go we don't have to, because it will not enter the product. So there will be no wear. So that's the concept.
okay, sir.
Very rarely it enters. Yeah. So let me ask a question. So if a go gauge is entering, and no go gauge is also entering the hole, so what is wrong with the hole?
It is below size requirement.
Below or above? Both are entering.
So above the size requirement,
Yeah. And suppose if go plug gauge is itself is not entering, then
below the size
yes,
requirement.
correct. So similarly, suppose we have a ring gauge and it is entering, and no ring gauge also entering. So what's wrong with the shaft? Is upper or lower?
It is below size requirement.
Correct. Okay, that's the whole concept about these limit gauges.
So, can you please repeat this previous point?
Okay. So when go ring gauge is entering and no go ring gauge is also entering, then shaft is rejected because these are ring gauges. Okay, in which you'll keep the shaft inside. If both are entering, what does it mean? It is undersized. Okay. Any doubt?
No doubt, sir.
Okay, thanks. So just so can anyone remember what types of materials we use for these gauges? Just in case if there is any question in the materials. What types of materials you'll use for limit gauges? So before that, I need very high hardness so that the wear will be less, and it should be good.
Surface
The
finish,
yes, correct, of course, surface finish. So
non-corrosive.
huh,
Corrosion resistance.
machinability, and there should be one more very important physical
तो
property.
कोफिशिएंट ऑफ थर्मल एक्सपेंशन लो होना चाहिए.
Yeah, that's correct. No corrosion, or it should be inert chemically. Okay, so can anyone name what are the materials covering these properties, having these properties? Can I take high carbon steel? Which is having chromium content, which is non-corrosive, good hardness steel, since the carbon is more, and machinability I
Machining.
cannot say, but still compared to other materials, it's fine, and as well as alpha is okay. So then we come. There is one more material EN24. It's a family of mild steel. This EN means European North. So they coined this material, so they just named it, which it has very good machinability and stability. It's a part of mild steel family. So then comes Invar. It has very low this coefficient of thermal expansion, so that's why we use it. But there is a catch in this. These can withstand very high temperatures. That is also one reason for this use, but they are very brittle, so this crack formation is very often in this inward. So that's why we generally prefer glass, which is having all most of the properties except machinability. So now so this concept of glass is very interesting if you think out. Suppose if a worker is using say a HCS any of this material, and he accidentally dropped this limit gauge, plug gauge or ring gauge. So there will be some the surface damage occurring. Suppose it's a go gauge, it will enter the product, so there will be some damage on the surface. So there is some damage, and this damage, if you are inserting into this any product that we are using, so it will create, if it creates any the marks on any of the product, so it is going to reduce the life of that product. So for example, these barrels you see, which are having very large barrels, so they are generally inspected using this. If there is any this surface marks on this, so they where there the crack will start propagating, and which is very dangerous when it is in use. So that's why this glass came into picture. So once if you drop this glass, that's it. That's life is done. It will break. So we have to take a new, uh, you know, a device, and you have to use it. So there's a concept of this using the glass in it, and so these are the types of materials that we use, and these are the concept. And so there are some violations of the stellar principle, as I said earlier. I'll just show you what how these ring and this gauges look like.
Sir, what
So
was the
generally,
second material?
this is a proprietary thing, EN24 they say. It's a type of mild steel family. This is coined by European. This EN means Europe, this N means North.
Sir, I want to ask a thing, sir. Sir,
Yeah,
glass limit gauges are used or not?
yeah, they are used.
Uh, sir, the issue that you told that there will be some mark left, so how it is resolved?
No, no, no. So that's the thing. Suppose if you drop the glass, you know, if you drop the glass, it will break instantly. If it because it has very less, the toughness. It's too brittle, so there is no chance of using it again. Suppose if you drop any high carbon steel or EN24, these are metals, so it has good toughness, so it will not break very easily. So the worker will immediately start using it. But if you provide them glass, they cannot use because it breaks.
सर मतलब ब्रेक कर जाएगा तो यूज ही नहीं करेंगे ग्लास को, तो फिर फायदा क्या है ऐसे लिमिट गेज का?
That is what we need. So we don't want to so unless you drop it, you can use it.
ओके सर.
Yeah.
Sir, means other materials may give bad results because of scratch,
Yes. Yes.
and that's why we are using glass.
Yes. Yes. Okay.
Okay.
So I'll just show you these types of how we looks, how these gauges looks. So basically, what we do is we just attach both the go and no go gauges in one side. With the handle. So this is the handle. So this is no go gauge. This is go gauge. Okay. These are plug gauges used for hole. Similarly, these ring gauges.
Sir, go gauge should be small in size. No?
Yes, yes. This is small in size only, right? Okay, these are ring gauges. And we have a marks here. So just for the worker, for the easy understanding of the worker. So just by seeing the mark, he can identify this is a go gauge and this is a no go gauge in ring gauges. This is how he looks, and these are made of generally Taylor. He says that you should use a solid full form go gauge, but they are too heavy, so that we remove some of the material and we will make it hollow, so that the workers can use it very easily. So there are some violations like this, and they are attached both the sides. Means they are in, instead of making two parts, they are simply in one part. Just with one inspection you can test both the upper and lower limit of the hole or the shaft. With shaft you have to do two, but for hole it's one time process. And this is called as snap gauge. Okay, where I attached both to one place. And individually, if I want to say, these are the plug gauges. Okay, any doubts?
Sir, these both are called snap gauges.
Yes, yes. Where you attach both go and no gauges, we call it as snap gauges. So
So
now,
the concept is valid for hole and shaft separately.
yeah,
Snap.
same. So there is one more thing. Before going to the questions, we'll solve questions very quickly. Uh, so do you think, suppose I have a hole, do you think this plug gauges that whatever I am using, I'm discussing for only the whole part so that it will be the exactly opposite for the shaft. So I'm using a plug gauge to measure the dimensions of this hole in a plate. Okay. Do you think it will check the quality or circularity of this thing?
नो सर। मतलब उसको रोटेट करके चेक करेंगे तब हो सकता है।
Okay.
Quality we can't check, sir.
What?
We can't check quality.
Okay. Unless specified, we cannot check the ovality or circularity. Suppose instead of this, I have say like this. Okay. So now it is elliptical, not square. But my no-go gauge will enter and sorry, go gauge will enter and no-go gauge. Sometimes it will enter if it is in within go gauge will definitely enter and no gauge also will not enter. Of course, because it is one dimension will restrict it entry. But still, this is not acceptable. But still, we are accepting it. So that's why this in this generally there will be no problem of the circularity because most of the products are standard. We use standard machine tools for producing this, so there will be no chance of circularity or ovality in these things. But if by chance if there is any special process you are using and if you want to check, instead of using a solid box, you have to use needles. So we have to keep two needles and check both the sides. Okay, in order to check these dimensions. Also, if you have a square shape, so you have in this it is easy. In this is also you have to take a needles and check, or you have to check two times by rotating as there is one idea. So you have to rotate the gauge and you have to check two sides. Okay, suppose this is my acceptable dimension L, and this is some L prime. You can say L prime is less than L, but still I will accept if I'm not rotating the plug gauge while inspecting. Okay, I have to check both the directions, and if it is fine, then only I will accept. So that's the concept. So generally it will not so if there is any question you have to say no unless they provide any additional things like checking in two directions if there is any question any descriptions with it. So that's the concept. So let's solve some of the questions regarding the last we discussed yesterday as well as today. These are all the gate questions. So we'll spend 1 or 2 minutes on each questions. So we can start this question.
Option B, sir.
B, sir.
Okay.
सर इसका तो 0.012 आ रहा था ना. Yeah, now it's okay.
So everyone is getting the value. We already solved this question. Okay. So let's move to the next question. I think you already solved. Just solve it for a second.
D.
Yes.
A.
C, sir.
C.
C, sir.
C, sir.
Okay.
C.
Oh, sorry. So the sorry. So the upper limit of the whole shaft is 0.004 and the lower limit of the hole is 0.002. So this difference is what the maximum interference, which is 20. So how you are getting 40 and 10? Any doubts? Understood?
Yes, sir.
Okay. Next question.
So that number,
Sorry, just give the option.
so that
ABC.
number, is it zero? The what? Lower limit.
This one.
Uh,
0. Yes.
okay.
Transition.
Option C.
Yes, sir.
C, right?
Transition.
Okay. Okay. Should not take this much time.
So transition. C.
Shall we move to next question?
Sir, what are those A and B options? Close running. Close running. When do we choose it?
What is loose running fit?
Yes, sir. Close running fit and loose running.
Was close running fit? Can anyone remember what is close running fit?
Closed tolerances, sir.
Okay. So I have provided this drive link in this the past lectures are there. So there is one lecture, introduction lecture casting. I think very few people attended it. So you can have a look once. So what is the close running fit here?
It is the type of clearance fit having the closed tolerances grades. Closed tolerances.
Okay. Something to do with the clearance fit. So let us move to the next question. So before that, just I have pasted the drive link. You can have a look.
Option B, sir.
Option B.
C, sir.
Okay.
A, sir.
Okay.
Fourth one A, fifth one B.
Okay. Spend some time. There is no hurry. So 1 minute you can freely spend on every question. So you'll have 3 hours. No need to worry. Spend some time. Don't click the wrong answers. Do you remember what is allowance?
Difference in fundamental deviation.
Okay.
Minimum clearance.
Okay. Yeah, there are so many terms. Can I say difference between max and material limits?
Yes, sir.
Okay. Okay. Let's move to the next question.
What was the answer of previous question?
Fourth question or fifth question?
Fifth. Fifth.
Minimum clearance. So you
Okay.
can directly strike off these two. Why?
These are for tolerance.
Yes, sir, they are not referring to the assembly.
False and shafts.
Yes, yes, correct. So here we have maximum and minimum. So the allowance is what we discussed is difference between maximum material limits, which is minimum clearance. Okay.
Okay, sir.
Yeah. Yeah. Sixth question.
D.
Interference field, sir.
Shall we move to next question? Or anyone is thinking?
Option D.
Hmm. So the upper limit of the hole is less than the lower limit of the shaft. Okay. Yeah, this is interesting question. You can solve.
Sir, it is 25 plus 0. Is it 2?
Option B.
No, your
Just
question, sir. It is not clearly visible.
this one. This is 2. This is also 2. Okay. Better?
Yes, sir. D, sir.
Okay. So one hint I can give is this keywords go max. If you follow this, it will be very easy.
D, sir.
D.
B for ball.
Okay. B for ball.
Second option.
Okay. Sorry. Okay. How much you are getting?
Twenty-five 052. Option B.
Okay. Anyone tried with the diagram for this?
Yes, sir.
So did you find it? Did you got the answer?
Thickness should be double, sir.
Okay. But which method do you feel easier, the diagram or this like as I showed here?
Diagram.
Okay. Okay, we are designing go gauge for maximum material limit. So you take everything maximum here. That's it.
Answer is
B. Ball. Okay.
Sir, it should be D, na, sir.
It should be D.
Ah, sir.
How much you are getting here?
I have added thickness 2 times.
Why?
Thickness of plating, I thought it is given for only one side thickness. So on double, it is pin, na, so it will be on both sides.
But did they mention on the question?
But generally, we take thickness above the surface.
Correct. Should keep 2.
Yes, sir.
Then how much you are getting? right?
Yes, sir.
Okay. Everyone is agreeing with the answer?
Yes, sir.
Okay. Okay. Just solve this. I will let you know the answer.
C, sir.
C, sir.
D, sir.
The go case controls the upper limit of the hole. Wrong. The no go case controls the lower limit of the shaft. The go case controls the lower limit of the hole. This is correct. The no case controls the lower limit of the hole. Which is wrong, right? No go case is for the millimeter limit. Lower limit of the hole is maximeter limit.
Yes, sir.
Uh, Small disclaimer: this is only for hole. Do you realize this is for hole?
So means, sir, like for shaft, it will also be maximum metal limit only, sir, for bow.
Okay.
For shaft, it will be upper limit of the shaft, no, sir, for bow gauge.
Yes, yes. That's right. This is wrong. Okay. There
Sir,
is one.
that was applicable for hole and shaft both, no?
What?
The go max and no go minimum trick. Is that
Yes, yes. Correct. Nice. This is the last question.
Yes, sir.
A.
A only, sir.
Okay. Anyone with option C? No.
So C can be, sir, but maybe most common means
Yes.
plug gauge.
Yeah. Yeah. Correct. So only snap gauges can be used for both, right? Or even if I'm inspecting hole or shaft, I can use both. But plug gauge is separately for hole. Okay.
Sir, isn't it that for snap gauge, it is mentioned it is for go and no alone, or snap gauge is both for hole and shaft.
So if it is for both hole and shaft, unless only if no gauge and go gauge and no go gauge are coupled as a single device.
Yes, sir. So we have a separate snap gauge for hole and separate snap gauge for.
Correct. Correct.
Yes.
And snap gauge stands for only checking hole dimensions. No?
Snap gauges.
Means they are there for holes only.
Okay.
And here they have mentioned for inspecting hole diameter, means the hole we have to check only one diameter.
Huh. Okay. So how
So
will you check hole diameter?
means for checking only one diameter, we will make only one plug so that it can check.
Okay. Okay. Nice. But they didn't mention the number of holes, right? Infecting hole diameter, but one hole diameter, two hole diameter. Okay, fine. Simple question. So coming to this question, so he is correct. Someone is pointed. So thickness is only once is on the both sides since it is cylindrical, and the correct answer is 25.084. Option D. Okay. Yeah, if you understand this thing, you can continue with your work. So this is the end of the class. So they have mentioned only this thickness. Okay.
Sir, for the three types of gauges you mentioned, workshop, inspection, and ISO.
Yes.
Like, which one is like most important to remember, sir? Because it's a lot to.
Uh, See, they can ask anything. They can ask design gauges from inspection method. They can ask anything, but ISO is main preferred. It is simpler. You know, if you can read the diagram carefully, it is simple. It looks complex, but if you know this workshop, if you invert, you will get inspection. And if you take go gauge from workshop and no gauge from inspection, it is ISO. If you can remember in that process, it will be easier.
Okay, sir. Sir, and if, for example, if we have a hole which enters both the no go and go, and then which means it is a larger hole, sir.
Correct. it is oversized.
Yes.
So if you carefully see, this is the lot. This is the area where we are actually accepting the products. See, it is more in inspection, less in workshop. And if you take this ISO, it is the in between these two. Yeah, that is for today. So, so we are left with these measurements, angular measurements, and then interferometry. So in next class, I will cover those things. Yeah. And then we also have this concept of screw thread measurements. So all these concepts is mostly related to solving geometrical problems only. So similar triangles, similar it's more or less geometrical thing. You just have to draw and solve this. So that I will discuss in the next class. If time permits, I will solve some numericals. Otherwise, we'll discuss in the final lecture. So, just let me know. Have you guys attended this casting lecture that is being taught by some other person?
Yes, sir.
Okay, so can you tell me what are the concepts they covered in casting? Gating design they covered.
Yes, sir. We solved the PYQ questions also.
Okay, so we covered everything then in casting, gating design, razor design, solidification time. Okay, okay, yeah, then that's it. Okay, then will you meet in the next Saturday? Before that, you can just see some of these problems which is related to angular measurements and screw thread measurements. Okay, and if you have any doubts in this metrology till now, we can discuss in the next class. Yeah. Thanks for
Sir,
it.
Wednesday no session.
There is no
Sir,
Wednesday session. Directly we have on Saturday only.
So next only on Saturday,
Yes,
right?
yes.
Okay, sir. Thank you,
Yeah.
sir.
Okay. And if you want
sir,
any, yeah, tell me.
sir, the video offline video available, sir, recorded.
Yes, yes. So I have provided a link in the chat. That is a drive where all the
Drive.
recorded lectures are there.
Okay, okay. Thank you, sir.
Okay.
Thank you, sir.
Okay. Yeah. Thanks.
You were saying something, sir.
Uh, I forgot. Sorry. So if you want any special topics to be covered, just let me know in the next class, so I can plan those things in the last final class. Okay. This is the fourth lecture, so we have two more lectures. So if you want any special topics related to this manufacturing, this metrology, just let me know in the next class. Otherwise, in the last class, what I plan to teach is this non-conventional process, that is ultrasound related to this water jet machining, abrasive jet machining, and ultrasonic machining, which will be over in very less time. Okay then, yeah. Thanks for attending.
Thank you, sir.
Okay.
Sir, only for next Wednesday